Alright, so it's very good, guys. Okay, so pitch, volume, and vibration is, pitch is what they call as a quality of sound due to the rate of vibrations. So what I like for you to do, Cameron, is I want you to take your wooden handle there and just kind of tap on the glasses. Okay, as far as pitch goes, do those sound the same?
Yes, sir.
So we could say that they each have the same rate of vibration. Is that right?
Yes, sir.
Cameron, Tristan, why don't you take yours and try tapping on the glasses now? Now, did those sound a little bit different?
Yes, sir.
Why do you think that is?
It's a different. They're made of a different material.
That's right. So that's all right. So we can tell that the wooden spoon or the wooden handle creates a different rate of vibration than the plastic handle. But all in all, as far as tone goes, they're pretty much the same all the way across, right?
Yes, sir.
Why do you think that is?
There's no.
There's the same amount of air in each glass.
That's right. So there's nothing but air in each of these glasses, and that's what the sound's just kind of going through, all of them bouncing back and forth without having to go through anything, just air. Okay. So Cameron, let's talk about vibration. What is vibration exactly?
Vibration is a small movement that makes noise.
Very good. That's very good. So I want you to picture this for me. Let's say, remember on Looney Tunes when Wile E. Coyote chasing after Roadrunner?
Yes.
Remember what happens when he runs into the wall?
Yes.
His hood vibrates.
Then he goes back and forth, and you kind of hear a little vibration sound. So that's what vibration is rapid movement that goes back and forth, okay? And then volume, whenever we're dealing with sound or anything in science, has to be measured. And sound and sound waves are no different. And we measure sound in something that's called volume, okay? And that's how sound is made. Volume. As a matter of fact, the definition of volume is measure of sound in decibels, okay? And so what I would like for you to do, Cameron, for us, is I want you to take some of the Kool-Aid that we've got here and pour a little bit in each glass getting a little bit more than the other, okay? Start off with a real little amount here, a little bit more, and then we'll fill this glass up, okay? Oh, that's good. Here, let me help you. We want just a little bit now. There you go. Pour. That's good. A little bit more. About halfway. There you go. And then fill that one on up. Good job, Cameron. A little bit more. A little bit more. That's good right there. Now,
They're about equal.
so as far as our experiment goes, what did we change?
We changed the amount of matter or water that is in the glasses.
That's right, and that also made a change in how much air is in each glass, right?
Yes, sir.
So basically, we gave each glass a different amount of air for sound waves to travel through.
Yes, sir.
What do you think is going to happen? Do you think it's going to get higher to lower or lower to higher as far as the sound?
Higher to lower.
Okay, well, let's test that out. Why don't you try that, Cameron? Try tapping on the glasses now. You're absolutely right. Why do you think this one sounds lower than this one?
Because this one has less air. It has more water than that one.
So it has more of an obstruction, it has more stuff for airwaves to go through. So the water, it kind of alternates the sound as sound waves travel through it. And so the more water there is, the more of an alternation of sound there is, correct?
Correct.
Okay, so what if we were to tap it with that one? Try it now. Try it now. There you go. Same thing, right? But did this sound the exact same as that wooden handle?
No.
Why?
It's made of a different material.
Because we're still dealing with a different pitch. We're still dealing with a different rate of vibration, even though it's the same result. You're getting the water still alternating the sound waves, you're still dealing with a different rate of vibration than you would with a wooden handle. Is that correct?
Yes, sir.
Okay. So, why don't we, what happens if we were to change the volumes of these glasses?
You could change some of, you could pour some of this
Uh-huh.
into that one and make this one have a higher pitch and this one have a lower pitch. And you could do the exact same
Okay.
with that one.
According to your theory, if we poured more water into here, we'd give this a higher pitch or a
No.
lower pitch?
Lower pitch.
Very good. So the more we pour in here, the lower pitch we would have.
Yes, sir.
Okay, and then it's the same thing here. Now, with sound waves, what's something else sound waves kind of create?
They create vibrations.
Vibrations, and then with those vibrations, they can make
Sound.
sound. Sound created can create music. Is that right?
Yes, sir.
So, actually, let me come around here. So, if you wanted to, you could actually take these and make music out of them. Right? So, tell me a song that we could make. If you wanted to make a song just by tapping on the different sound waves, what's one that we could do?
Jingle bells.
Jingle bells. Well, Christmas time is coming. So, why don't y'all play with that for just a second? Play with changing the different volumes of the water and changing the pitch and the tone of the water, and see if you can kind of create your own jingle bells out of the two glasses. There you go. How about you, Cameron? What would you need to do? What would you need to pour more of this into here or more of this into there?
More of this into here.
Into there? Okay. Good job. Let me see. So you've got these pretty close to being the same, huh? Which one sounds lower? That one. So obviously this one has what?
More.
More water, more matter for the sound waves to go through. Same thing here. Looks like you've got these pretty close to being level. So let's tap on one and tell me which one's higher, which one's lower. Can you do it for me, Cameron?
This one's high, this one's low.
So then that would mean that what were we saying about this one?
That one has more water in it.
More water. Very good, guys. Very good. All right. So that is pretty much it for today. Now the best thing about working with Kool-Aid is what?
You can drink it.
Absolutely. So y'all have at it. Good job. Y'all did a great job.